Okay, assalamualaikum and very good evening. So today we will do lab 3, which is decoder and encoder. So to keep this video simple, we will go straight to procedure. So part 1, first we will do decoder. The type of decoder is 74138. For Proteus, we will use this type 74LS138. There are 3 input and 8 output. So for the first part, we will use combination of binary input to get the output for the decoder based on the table. So the table is here. So for G1, for in Proteus, G1 is E1, G2A is E2, and G2B is E3. So G1 we set to 1, which is we have the input power here, and both G2B and G2A is 0, which is no input. So for the first combination is 0, 0, 0. The output you will get Y0 is equal to 0. And if A is equal to 1, Y1 is equal to 0. So we go to the next input 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So this is the true table that we get from this simulation. And then we ignore the input. We will remove the input. And we set G1 and G2B is 1. So we set E1 and E3 to 1 and G to A is 0. So the output is all is equal to 1. And then for G1, for 1, 1, 1 here, the data switch. So all the data switch is equal to 1. And the output we get is also equal to 1. All is equal to 1. And then if G1 is equal to 0 or E1 is equal to 0, and the rest is equal to 1, you still get all the output is equal to 1. Okay. For the second part, which is encoder, we will use this type, which is 744148. In Proteus, we use 74LS14A. So the lab asks us to get the output according to the truth table, which is here. So we can ignore A0. 0 we can ignore the input. So first we see the output for B here. So we set all is equal to 1. Wait Okay, so let's say we set A1 is equal to 0. Here is A1 is equal to 0. So the output will be 110. 110. And if A2 is equal to 0, the output is 101. And the rest, and if A3 is equal to 0, the output will be 100. And if A4 equal to 0, the output is 011, and the rest. And if all is, and if A7 is equal to 0, and the output is will be all equal to 0. Okay. For digital display, we will remove this, put the digital display. Okay. If A is equal to 0, the digital output will be 6. And if A1 is equal to 0, the output will be 5. And if A2 equal to 0, the output will be 4. And the A3 is equal to 0, the output will be 3. Sorry, A4 equal to 0, the output will be 3. F5 equal to 0, the output will be 2, and the rest until 0. And then for the output inverter, we need to put the not gate because it is inverter. So basically the inverter is opposite of the output here. So let's say if A1 is equal to 0, so the output will be 001. It's the opposite of the previous lab. So 001. So if this output is 101, so the output for inverter is 010. 010. Okay. As for the digital display, If A1 is set to 0, the output will be 1. And if A2 is set to 0, the output will be 2, and it will be go one by one, 3, 4, 5, 6, 7. Okay, that's for part 2. For part 3, the question is we need to do the circuit diagram for this decoder to get this truth table. So the circuit diagram that I build is like this. The logic it consists of NOT and N. So let's say if it's equal to the table that it provide. So let's say the the input is 0 0, the D naught is equal to 1, and the rest is 0. So let's say the input is 0 and 1. 0 and 1, the D1 is equal to 1. And if the input is 1 and 0, it will be 1 here. And if both is 1, 1 is here. Okay. So the output and input is according to the truth table here. As for question 2, we need to use 74LS139N to build from 2 to 4 decoder. We have to build 3 to 8 decoder. So this is how I build. Okay, and this is a truth table. So basically, if the input is 0 0 0, the output of D naught is 0, then the rest is 1. If the input is 0 0 1, the D1 is equal to 0 and the rest is 1. If the input is 0 1 0, the D2 is equal to 0. So it will go down. So if the output is 0 1 1, this is become 0 1 0 0, 1 0 1, 1 1 0, and 1 1 1. Okay, and that's all for today's lab. So thank you.